Hello and welcome back to another holistic education video. In this video, we'll be continuing our series on the 25 hardest SAT math problems of this year according to Prep Maven. In this video, we'll be tackling problem number 3, which states, in the xy plane, the point PR lies on the line with equation y equals x plus b, where b is a constant. The point with coordinates 2p, 5r lies on the line with the equation y equals 2x plus b. If p does not equal 0, what is the value of r divided by p? And it gives us the options of 2/5, 3/4, 4/3, or 5/2. Now this is an interesting problem because it's talking about lines and it looks like it is a geometry problem, but it is really more about solving systems of equations. And how can we see that? Well, if you think about what a line represents, let's say we have our xy plane. We have some sort of line on that plane with some equation y equals mx plus b. And then we have some point on that line, let's say point xy. Then what this is saying is that this point satisfies this relationship described by this line equation. So when we look at these points and these lines, we're really talking about relationships. So what does that mean? So it says point PR lies on the line y equals x plus b. And that means that we can take this p, plug it in for this x, and this r, plug it in for this y, and get the relationship between those two variables. And if we do that, we'll see r equals p plus b. And the same thing is true for our other point, 2p, 5r, on the line y equals 2x plus b. We plug that in, we get 5r equals, and this 2 is multiplied by what we're plugging in for this x, which is the 2p, plus b. This, of course, can be simplified to just 4p plus b. And so now I'll write it up here. This 5r equals 4p plus b. We have two equations which give us information about our variables, and so we can solve this as a system of equations. So in order to do that, we will take our value of r, which it says here is equal to p plus b, and we will plug it in for our r value here to just get p isolated. We do that, we get 5 times p plus b equals 4p plus b. And we multiply out these parentheses, we get 5p plus 5b equals 4p plus b. We can subtract 4p from both sides, and that will give us p plus 5b equals b. Subtract this 5b from both sides, and I'll write this over here. We get p equals negative 4b. So now we have a value of p in terms of b. Now we can take this value here and plug it back into our original equation of r equals p plus b. Take this value here, which we say is equal to this p, and plug it into this p. We get r equals negative 4b plus b. And of course, negative 4b plus b equals negative 3b. So we end here with p equals negative 4b from up here, and we have r equals negative 3b from right here. And this is what we get when solving the system of equation. Now, a thing to keep in note, because our original system of equation had 3 variables and 2 equations, we would not be able to solve for a numerical value, but we can get these values in terms for b, which is all we need, because if we look back at the original equation, what we're looking for is not the numerical value of r and b, but the ratio between them, r divided by p. And we can plug our values here in for that to get negative 3b on the numerator and negative 4b on the denominator. And here, this is where things work out. This b on the top cancels out this b on the bottom, and also this negative cancels out with this negative, and we'll end up with 3 over 4, which means as long as this b value does not equal 0, and hence this p value does not equal 0, the ratio between r and p is always going to be 3 over 4, or 3/4, no matter what the value of b is. And so this right here is our final answer, which means our final answer is option B. Thank you so much for tuning in, and I'll see you in the next one.